Yo, 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 yo. Okay, we're going to solve quadratic equations by completing the square. So this is the first method we're going to learn on how to solve quadratic, not the first, but it's the first one that we're going to learn for when they are not really factorable. Okay, so this is one strategy when we can't factor the quadratic equations. We could technically solve by graphing when it's not factorable, but as we know, factoring is not a very efficient way of graphing is not a very efficient way of solving a quadratic equation. So when it's not factorable and I can't solve by factoring, one possible way is to solve by what's known as completing the square. So completing the square is a process of adding b over 2 squared to the x squared plus bx to form a perfect square trinomial. So we're going to look at that right now. So this big part right here is this b over 2 squared. So that's what I want to do is I want to learn how to make this a perfect square trinomial. So we've seen perfect square trinomials before. That's something when I have like x plus 3 squared, okay, or x plus 2 squared. So that's when it's a perfect square trinomial. Now, we've learned the shortcuts of how to go from here to here, but now we're going the other way. So for c, in order to make this, what value of c would make this a perfect square trinomial? Really what I can do for that is I take that b over 2 and I square it, and that's going to make this a perfect trinomial. This formula, or this little mini formula right here, will make this a perfect square trinomial if I use it. And that's when I don't have a c value. So if I take 6, because 6 is the b value here. We know this is ax squared plus bx plus c. So the b is always the one with attached to the x. So if I take this 6 and I divide it by 2, and then I square all that, well, that's 3 squared, which is 9. So the value for c to make this a perfect square trinomial is 9. And let's look at if that worked. If I plug in a 9 here, well, I'm looking for factors of 9 that add up to 6. Well, 3 times 3 is 9, and 3 plus 3 is 6. So it's x plus 3 and x plus 3, which is x plus 3 squared. So that makes it a perfect square trinomial. So this process is what we're going to be using to complete the square and solve these. So I'll show you how we can use this. But first, I want you to find the value of c that would make this a perfect square trinomial, because we have to have this skill. So try it on your own real quick. Use that formula. So if I take whatever my b is and I divide it by 2, that's 6. So I have to square 6 to get 36. So the value for c is 36. And again, square root of 36 is 6, and 6 plus 6 is 12. So if I were to factor this, it would be x plus 6 squared. Okay, so now we understand how to complete the square. Okay, this is called completing the square. It's this process. Is this value for c. So what we're going to do is we are going to solve this by completing the square. So first, if I look at this, I have x squared minus 14x plus 16 equals 0. I cannot factor. There are no factors. I cannot solve this by factoring. There are no factors of 16 that if I add them up, it gets negative 14. This is not factorable. So this is where I'm looking at, okay, I can't solve this by factoring. So what I want to do is I want to solve this by completing the square. But for us to do that, if you looked over here, we didn't have a c. So we did this whole process to add a value for c. But right now I have a c. So what I'm actually going to do is I'm going to get rid of it. And I'm going to subtract c, 16, from both sides. And that gives me x squared minus 4x equals negative 16. I know we like to have it equal to 0. Okay, but I'm going to show you, but right now we don't want it equal to 0 because I want to be able to complete the square. I want to be able to make this a perfect square trinomial because I can factor a perfect square trinomial, and then we can solve it after that. So I subtracted 16 from both sides. I didn't change anything because we're properties of equality, right? I did the same thing on both sides of the equal sign. That's fine. So now what I'm going to do is I'm going to add that value for c that makes this a perfect square trinomial, but I have to add it to both sides. So what I'm going to do is I'm going to take that x squared minus 4x, and I'm going to add that b over 2 squared. But whatever I do on one side of my equal sign, I have to do it on my other side of my equal sign. So I'm going to add this to both sides. Well, what this is I can actually plug that in, right? So, I'm sorry. So, what negative b squared, what b over 2 squared is, oh, you know what? I copied this down. That's a 14. I'm like, I knew something was off. Sorry, that was 14 the whole time. I just forgot to draw the 1. Okay, so b over 2 squared, that's going to be 14 over 2 squared. So that's 7 squared, which is 49. Okay, so I'm going to add 49 to both sides. I'm ignoring this negative sign right now. Okay, and I'm going to add 49 to both sides. We still are just going to add it. We're not subtracting it. So I'm going to do x squared minus 14x plus 49, and I'm going to do that on both sides. Now, typically speaking, you don't have to write this b over 2 squared in there. I'm just showing you what we're doing. I'm taking this value, because I know this will make a perfect square trinomial, and I'm adding it to both sides of the equal sign. Okay, so I haven't changed anything, but now this is a perfect square trinomial, because now I know that I can do x minus 7 times x minus 7, and I can factor this out. Because negative 7 times negative 7 is positive 49, negative 7 plus negative 7 is negative 14. So it wasn't factorable in the beginning. I moved over this c value, then I added, and then I worked on completing the square to make this a perfect square trinomial. And then now this is what I've got so far. We've got x minus 7 times x minus 7 equals 33. So what I want to do from here is, now that I have this, I know this is really just x minus 7 squared, right? Now I can solve this by taking the square root. Well, if I take the square root of all of this, and I take the square root of both sides, that cancels out the square. So I really just have x minus 7 equals the square root of 33. I don't know what the square root of 33 is. So since I don't know what the square root of 33 is, I'm just going to leave it as square root of 33. I'm not going to do anything with this right now. And now I am going to solve my equation. But what I do know is I know that the square root of 33 is going to give me a positive and a negative number. And that's going to be, and that's important because that gives me my two solutions. Okay, so what I'm going to do from here is I am going to now add 7 to both sides. So I got to get x by itself still. So my equation is just x minus 7 equals positive square root of 33. But I also have the equation of x minus 7 equals negative square root of 33, because we know it's going to give me a negative number as well. It has two solutions, a positive and negative, or whatever the square root of 33 is. So when I add 7 to both sides, I'm going to have a positive 7. But I'm either going to be subtracting the square root of 33, and I'm also going to be adding the square root of 33. Because the square root of 33 can be positive or negative. So those are my two final solutions. We actually leave it like this. Okay, we're not going to simplify anymore. We're going to leave it as is because we don't know what the square root of 33 is. We're not going to approximate right now. We're just going to leave it like this. So my answer to this particular, the solutions for x are 7 minus the square root of 33 and 7 plus the square root of 3. And the reason why I have minus and positive is because of this plus or minus the square root of 33 in the front. So there's a lot here, okay? So we're going to keep practicing. But let's look at another example just so we can see it again. Okay, if you want to pause it and try, you can, but if you want to watch, watch. So again, I have, there are no factors of negative 9 that are going to give me a positive 10. Okay, it's not possible. So because of that, I need to solve by completing the square. It's not factorable. So the first thing I'm going to do is I'm going to get rid of the c by adding it to both sides. And then I'm going to work on completing the square from here. So I have x squared plus 10x equals 9. So now I'm going to add this b over 2 squared to each side. Well, that's 10 over 2 squared. So 5 squared is 25. So I got to add 25 to both sides. So plus 10x plus 25 equals 9 plus 25. So I added 25 to both sides. Now I can factor this out because it's going to be x plus 5 squared. And the reason why it's x plus 5 squared is 5 times 5 is 25, 5 plus 5 is 10. So it's now factorable. And then I actually have to multiply this out, which is 34. Okay. So now I have my equation that I can solve, because now I can take the square root of this to cancel out the square, and I can do it on both sides. So really what I have is x plus 5 equals the positive and negative answer for square root of 34. Well, if I subtract 5 from both sides, that gives me a negative 5. So I have x equals negative 5 plus the square root of 34, and I have x equals negative 5 minus the square root of 34. And I'm done. There's nothing else to do here. We're good to go. Okay. So now, for this one right here, we have a value here for a, okay? But what I'm going to do is I'm still going to work on completing the square, but I'm also going to be able to divide this. But we'll divide that afterwards. So first what I want to do is I want to get rid of the c. So I'm subtracting 16 on both sides. So I have 2x squared plus 12x equals 5,600. Now, all of these are divisible by 2, so let's just divide everything by 2. That's gone. So I have x squared plus 6x equals 2,800. Now I can work on completing the square. So now I can figure out, okay, so b over 2, that's 3, squared is 9. So I can add 9 to both sides. So I'm adding 9 to both sides. And that's going to give me x plus 3. And that's going to give me over here 2,809. Now I can take the square root of both sides. That cancels it out. I have no idea what the square root of 2,809 is. It might be a perfect square. So it's always worth, especially with these larger numbers when we just don't know. I could plug it into a calculator real quick, and it actually is 53. So this gets me x plus 3 equals positive or negative 53. Now I can just solve because I have my two possible solutions, right? Because the square root of 2,809 is either positive or negative 53. So now I can subtract 3 on both sides. So I have x equals, let's see, this is negative 3 plus 53. And then I have x equals negative 3 minus 53. Well, I can actually solve both of these now because now I know this is what it is. So x equals 50 and x equals negative 56. And what I did is I just combined negative 3 and positive 53 to make 50, negative 3 and negative 53 to make negative 56. So here's my solution. So this one worked out pretty well, actually. So this actually might have been factorable. Okay, it probably was factorable, and I just didn't know it. I could have divided by 2 everything, and I could have actually factored it, but no idea what those factors were. And so this was just an easier way to get there because I can factor while completing the square. Okay, so now we're also going to use completing the square to write in vertex form. Okay, so again, right here, not factorable. There's no factors of 11, so I can't get them to negative 8. So let's work on completing the square. So let's move over that 11, but I'm going to keep the y there because this is, I want to convert to vertex form. So if I subtract 11 from both sides, that's going to be y minus 11 equals x squared minus 8x. I don't know why I wrote 18x, I'm sorry. So I'm keeping the y here because this is the original equation. I got to maintain that equality and keep this. And I'm subtracting 11 from both sides. Now I have to do my b over 2 squared, right? And that's going to be 8 over 2, which is 4, squared is 16. So I'm going to be adding 16 to both sides. Well, negative 11 plus 16 is 5. And then this side over here, I can actually factor this. This is going to be negative 4 because this is a perfect square trinomial, but the middle term is negative. So that's x minus 4 squared. Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. So here's my perfect square trinomial. If you look here, it's already almost in vertex form, because vertex form, we have this parentheses squared right here, right? This gives me my x coordinate, but normally we have y by itself. So now I can move that 5 over. And this should look like vertex form, right? And now I can easily graph this if I want to, instead of having to graph it from here. So by completing the square, if we don't like graphing in standard form, I can complete the square, and now I have vertex form, and I get to graph my function if I want to. And I know my vertex is 4, -5. Okay. I think this is one of our last problems, yeah. So this one right here is we're gonna write in vertex form so that we can figure out what the maximum altitude reached is. The maximum value for this is gonna be that vertex. Okay, so that's why I wanna write it in vertex form if I don't, and I have a function right here of a equals -5t squared plus 80t plus 9,000. That 9,000 gives me my y-intercept. It does not tell me my maximum altitude. So let's complete the square. So I'm going to subtract 9,000 from both sides. That gives me a minus 9,000 equals -5t squared plus 80t. So from here, what I can do is I can factor out a 5 first. Okay, and I'm going to factor out, a -5. So if I factor out a -5, that's going to leave me with t squared minus 16t. And the reason why I did that is because I don't like having that a value there, so I'm going to factor it out, and this is already starting to look like vertex form. Now I can complete the square of just this guy inside here, because this is what I'm trying to complete the square. This is when I'm trying to have a perfect square trinomial that I can take out. So again, it's b over 2, so that's 16 over 2, which is 8, squared, which is 64. So I'm going to add 64 to both sides. I'm keeping everything in parentheses here because now this is what I can factor. Because that's a perfect square trinomial. It's going to be -8 and -8. So it's t minus 8 squared. This is starting to look like vertex form. Okay. And this over here is one thing I forgot to do. I just realized there. I'm like something went wrong here. So I'm sorry. So let me backtrack a little bit here. And I apologize for this mistake. So when I had factored out this -5, and then I added 64 to both sides, am I really adding 64 to this right side? I'm not. What I'm adding is I'm adding 64, but this 64 is being multiplied by -5. So to maintain that equality, I also have to multiply this 64 by -5 as well. So I apologize for that. So when we have to factor out an a term, and then when I complete the square, I have to multiply by whatever that a term is on both sides, because that's going to maintain equality. Because this is in parentheses, this is all being multiplied by this -5. So because of that, because this is really -5 times 64, I have to add -5 times 64 on the left-hand side. Like I knew something looked wrong. I apologize. That was an error on my part. So I need to do 64 times 5. Which is 320. So that's minus 9,000 minus 320. So that's a minus 9,320 equals -5 times t minus 8 squared. That looks a lot better now. Now I can finally add 9,320 on both sides. So in vertex form, this is going to be -5, so there's my, it's not my slope, but that's the amount that it's changing by, right? And then plus 9,320, so the maximum altitude is 9,320 because that's the y value of my vertex. And I am done. So I apologize for that mistake. So again, we completed the square. But because we had to factor out that -5 in the beginning, this -5 is being multiplied by everything in here, which means that when I added 64 to both sides, I had to multiply that by -5 on both sides to maintain that equality. Okay. Now we're all done. Okay, so things to remember, b over 2 squared. Super important that we remember that. there is, I want you to write this in vertex form by completing the square. And that's your independent practice. Thank you for watching. That's all I got for you guys. Good use out.